Hello students, welcome to chemistry class. Today we are going to study chemical properties of haloalkanes. So I am taking the examples of haloalkanes. We have here bromoethane. Bromoethane. So the reactions of bromoethanes with aqueous KOH, or we can also use aqueous NaOH. When bromoethane react with aqueous KOH or aqueous NaOH, the product form is alcohol. That is the equal number of carbon content here, CH3CH2OH. This is a nucleophilic substitution reactions. Here Br is substituted by OH. So the aqueous KOH or aqueous NaOH is it. The product is ethanol. But if we use alcoholic KOH or NaOH, the product form is not alcohol. Here is the elimination reactions is occurs. That is a dehydrohalogenation here. It means hydrogen and halogen is removed from the carbon. Halogen removed from one carbon and hydrogen is removed from another adjacent carbon atoms. So the product form is CH2 double bond CH2, and this is the type of elimination reaction. And this is the ethane. This is dehydrohalogenation. When haloalkanes bromoethane react with alcoholic Cation potassium cyanide, the product form is again the nucleophilic substitution reactions, that is a CH3CH2CN. Here in potassium cyanide the bond is ionic bond, therefore the product form is cyanide compounds. This is ethyl cyanide. When this ethyl cyanide on partial hydrolysis, in partial hydrolysis we use 1 mole of water, then the product form is amide, that is CH3CH2 C double bond O and H2. This is propanamide. This is what? Propanamide. Here, starting from 2 carbon, the product form is 3 carbon. Okay, so for the increase in the number of carbons, we can use alcoholic cation, or if we use on complete hydrolysis, we use 2 mole of water. Then the product form is CH3CH2COOH, that is a carboxylic acid, propanoic acid. Okay, so here we get propanoic acid and the intermediate product is amide, and when we use another mole of water, then the carboxylic acid is formed here. And again, if you reduce ethyl cyanide in presence of sodium and ethyl alcohol, it reduces to amine. The amine is CH3CH2. Hydrogen is present in now CH2 here and NH2. This is the 1 degree amine, and you can say propanamine. This is what? Propanamine. So we can convert haloalkane to amine. Sorry, this is not amine, this is amide. Okay, this is what? Amine. Also, you can use another reducing agent like lithium aluminum hydride, then the product form is also propanamide. amine. Again, bromoethane CH3CH2Br. This is a bromoethane. Bromoethane. When react with alcoholic KCN, we said the product form is CH3CH2CN, cyanide, ethyl cyanide. But if we use alcoholic AgCN, the product form is isocyanide, CH3CH2NC. In AgCN, there is a covalent bond, so NC is formed here. That is isocyanide. The name of this compound is ethyl isocyanide. Ethyl isocyanide. And if we reduce this ethyl isocyanide in presence of a strong reducing agent, then the product form is CH3CH2NHCH3. And this is a 2-degree amine. And the name of this compound is N-methyl ethanamine. Okay, so we can convert haloalkanes into 2-degree amine by using alcoholic AgCN. So another reactions here, when haloalkanes react with potassium, potassium hydrogen sulfide, then the product form is here CH3CH2ESH. This is ethanethiol. The product is ethanethiol. Similarly, when haloalkanes react with ammonia, alcoholic ammonia, we use here alcoholic ammonia, the product form is CH3CH2NH2. Yes, this is the amine with the equal number of carbon. This is the amine with the equal number of carbons. That is the ethanamine. Next reactions, when haloalkanes, that is CH3CH2Br, bromoethane. When bromoethane react with sodium metal, in presence of dry ether, the product form is alkane with double number of carbon in haloalkanes. So there is a 2 carbon in this haloalkanes. So product form is 4 carbon, that is a CH3CH2. Here is a CH2 and CH3. The product is N-butane, or we can say butane. N-butane. This reaction is called Wurtz reaction. Very important reaction, Wurtz reaction. Similarly, when haloalkanes react with magnesium in presence of dry ether, then here addition reaction favor. So the product form is CH3CH2NZBr, and this is Grignard reagent. So we can say ethyl magnesium bromide, and this is Grignard reagent. This is what? Grignard reagent. When this Grignard reagent is react with water, the product form is alkane, CH3CH3. Here in water there is a H plus and OH minus. So H plus goes to this carbon and OH minus bonded with Mg. Here Mg is positive and carbon is negative. So the product is CH3, that is ethane, and MgOH, Br, magnesium hydroxide bromide. The name of this product is ethane and another is magnesium hydroxide bromide. Therefore, Grignard reagent is very sensitive to water. Again, when haloalkanes react with potassium nitride KNO2. Potassium nitride, there is a ionic bond, therefore the product form is CH3CH2ONO, and the name of this compound is ethyl nitrite. Name of this compound is ethyl nitrite. But if we use silver AgNO2 silver nitrite, then the product is CH3CH2NO2. We know that AgNO2, in AgNO2 there is a covalent bond, so this nitrogen attack this carbon in Br containing carbon. But in KNO2 there is a KON double bond O. So this oxygen attack to carbon in KNO2. But in AgNO2, due to the covalent bond, this nitrogen attack to the carbon which contain Br. So the product form is nitroethane. So let us see another reactions here. I am taking CH3, CH2, Br. This is bromoethane. We can also take chloroethane. Yes. So bromoethane, when react with alcoholic silver nitrate AgNO3. If we use silver nitrate, then there is a formation of LOPPT. This LOPPT is due to the silver bromide AgBr, formation of the LOPPT. Again, these haloalkanes, bromoethane, when get reduced with H2Ni at about 300 degrees Celsius or 573 Kelvin temperature, then haloalkanes, bromoethane reduced to ethane, that is CH3. The formation of ethane here. So bromoethane reduced here, and the minor product is HBr. Again, when bromoethane react with dry Ag2O, and I am taking here moist Ag2O. Okay, so the meaning of moist Ag2O is when Ag2O react with moist, that is water, then it gives AgOH, silver hydroxide. Therefore, in moist Ag2O, bromoethane gives CH3CH2OH, that is alcohol. But when react with dry Ag2O, it gives CH3CH ether, that is CH3CH2O, CH2CH3. Okay, we use 2 mole of bromoethanes when react with dry Ag2O, and the formation of ether here, the product name is diethyl ether. Or IUPAC name is ethoxyethane, and this is ethanol or ethyl alcohol or ethanol. Again, if we react bromoethane when react with sodium iodide in presence of acetone, the product form is iodide here, that is iodo C2H5I, that is ethene, iodoethene plus NaBr. So these are the very important reactions. Again, I'm taking another reactions here. I'm taking CH3 CH2 Br when react with zinc metal in presence of dryth, then product form is CH3 CH2 again CH2 CH3, that is a double number of carbon alkane, that is a N butane plus ZnBr2, and this reaction is also called Frankland reaction. Again, this CH3 CH2 Br, that is a bromoethane, when react with, I'm taking another reactions here, when react with Br2 in presence of sunlight, then the product form is C2S4Br, which on further react in presence of sunlight to give C2H3Br3. Okay, like here Br2, when react with Br2 in presence of sunlight, the bromine, this Br form to Br2, and in presence of sunlight again it gives Br3 here, and again if in presence of sunlight then it further gives C2H2Br4. Here number of bromine is increasing. Okay, similarly another very important reactions, when it react with R2Cu Li, then the product form is RCH2CH3. Here the elimination of RCu plus Li Br. This reaction is called Core-House synthesis. This is very important to form alkanes with required number of carbon. Core-House synthesis. When this bromoethane react with lead in presence of sodium alloy, the product form is TEL, that is tetraethyl lead. For molecular formula for tetraethyl lead is C2H54 PV. Yes, then the minor product is sodium bromide. This is tetraethyl lead.